Hi, hello, good morning. This is Nageswar Rao, Assistant Professor from AML Department, St. Martin's Engineering College. Today I am going to discuss Introduction to Machine Learning. A definition of machine learning. Machine learning is a subset of artificial intelligence which is used to develop the algorithms to learn the computer by self through tasks by experience. Basically, we know about all general languages in machine languages. In traditional programming language, we are giving data or program as input and we are getting as a output from the input. But in machine learning language, it is simply opposite to traditional programming language. Here we are going to give the data and output as a input and we are getting the output as a program. By using machine learning, we can perform different tasks. Here are some examples are there. We can detect spam mails and we can forecast stocks, and we can find out the user preferences. We can find our photo from the group of photos. These type of problems we can solve by using machine learning. Coming to types of machine learning, mainly we have 4 types in machine learning. First one is supervised, second one unsupervised, third one semi-supervised, and fourth one reinforcement learning. Supervised learning is one of the model in machine learning. It is used the only labeled data to train the model, and here labeled means by getting the output from the features. Here we can see diagrammatical representation for the supervised model. Here we are giving the input raw data. In the raw data, we have in noise data also, noise data and empty data also. But here we are giving labels in the raw data also. After that, the raw data will going to model in supervised model. Supervised model will select the one algorithm based on the what is the requirement or what is the problem. Based on the requirement or problem, supervised model will select the classification or regression algorithm. Based on that, the data will processed, and after that we will get the output with the labeled. Here we can see in the raw data, we can find the elephants, camels and cows. Finally, we get elephant, camel, cow differently with labeled. Okay, now we are going to see the categories in supervised model. First one, in supervised model we have classification. Second one, regression. Classification is nothing but it deals with the categories of variables. For example, we can say we can classify the mails as spam or unspammed or draft messages or sent messages. Like this, we can classify the data by using classification. In classification, we have different algorithms are there. First one is logistic regression. Second one, KNN algorithm. Third one, Navi Bayes. Fourth one, random forest algorithm. Fifth one, decision tree. Sixth one, support vector machine, SVM. Okay, now we are going to discuss regression. What is the regression? Regression deals with the type of numerical values or sequential numerical problems. For example, we can say by predicting the house price. Here, numerical continuous sequence means we want to find out the 1000 square feet price for the house. but we know the 500 square feet is original data and 100 square feet is original data. We know these values, but we don't know 1000 square feet. Like this type of problems we can solve by using regression algorithm. In regression algorithm, we have multiple okay, in regression algorithm, we can use multiple algorithms. First one, linear regression. Second one, lasso regression. Third one, ridge regression. Fourth one, decision tree. Sixth one, random forest algorithm. These are the sum of algorithms we can use in regression model. Now we are going to discuss unsupervised model. Till now we discussed supervised model only. Now we are going to discuss unsupervised model. Unsupervised model will allows the unlabeled data to train the model. Here unlabeled means we are giving only raw data. Here we don't give the any label for the raw data. By using raw data only, it will find the patterns, and after that it will give the predictions based on the raw data. Here we can see diagrammatical representation for the unsupervised model. In one second. Okay, here we can see the diagrammatical representation for the unsupervised model. In unsupervised model, we are giving the raw data without labeled. Here we can see we don't give the any label for the raw data. Here we can see from the raw data, the model will interact with raw data, and after that we'll select based on the problem, we'll select the algorithm. After that, algorithm will process the data, will give the output with the predictions, correct predictions based on existing data. In unsupervised model also, we have two types of categories. First one, clustering. Second one, association rules. Here clustering is nothing but grouping the data points or data based on similarity. Based on similarity, we can grouping the data is nothing but clustering. We can use different types of algorithms in clustering. First one, K means clustering algorithm. Second one, mean shift algorithm. Third one, principal component algorithm. independent component algorithm. These are the sum of algorithms we can use in clustering. After that, we'll go to association rules. Association rules is nothing but it gives the rules in the presence of one item set to the another item set. For example, we can say if we want to buy the one laptop, we need operating system also parallelly to work the laptop. In this situation, association rules give the suggestion to buy the operating system with a laptop. These type of problems we can solve association with association rules. Mainly association rules are used in marketing field to develop the marketing. In association rules also we have some of algorithms we have. First one ECLAT, second one a Prairie algorithm, third one FP growth algorithm. These are some of algorithms we can use with the association rules. Next we will see semi-supervised learning. Semi-supervised learning is nothing but it is the combination of supervised and unsupervised. It means in the semi-supervised learning, the model will use the sum of labeled data and sum of unlabeled data. This is the diagrammatical representation for the semi-supervised learning. Here we can observe sum of unlabeled data we are giving as input and sum of labeled data we are giving as input. Based on these two data, it will process with the model. After that, it will select algorithm based on the requirement or based on the problem. It will process the data. After processing, it will test with the data. Testing means here we are giving the raw data means 100%. In this 100% of raw data, 80% of data will use for the training, and after that remaining 20% of data will use for testing purpose. This is the test data. After that testing only, it will gives the performance analysis. Okay, performance analysis is a prediction. Based on prediction, we can analyze how much percentage we can get the performance by this model by using different performance matrices. Okay, here in machine learning we have different performance matrices are available. For example, accuracy, confusion matrix, R1 score, F1 score. These are all sum of performance matrices, and Euclidean distance formula, root squared mean error formula. These are all sum of matrices using in machine learning. Next one, reinforcement learning. Reinforcement learning is it is a technique in machine learning, and it interacts with the environment, and agent will get the profit or any rewards by moving best step, and it will agent will get the penalty for the wrong step by taking actions. We can see diagrammatical representation. We can see diagrammatical representation for the reinforcement learning here. Here the agent will take the action based on action, based on the action taking based on environment, and agent will get the reward for the correct move, and agent will get the penalty for the wrong move. Sum of key terms in machine learning. For example, we are giving the data, raw data to the model here. What type of data we are giving is the main important in machine learning. Here I am giving sum of data with features and label. This is an example of supervised model. Because of we are giving label also here. In supervised we don't give the any labels, but here I am giving label because this is the supervised model technique. Here we can observe sum of columns. Columns are nothing but features. These are the values for the features. After that, based on the feature values, we can select the label. We can create the one label here. Next, features. In diagrammatic, already we explained what is features. Features are columns for the table. In every column, we have different values for the every feature. Based on feature only, we can select the or we can define the label. Here, this is the label. Label is creating based on features only. Next, model. Model is the relationship between features and the label. Till now we have discussed what is feature, what is label. The model is relationship between feature and label. We can see diagrammatical representation here. What is the model? Data plus algorithm equal to model. Here data is giving to the algorithm. After that, algorithm will train in data, will give the output as a model. Total these two performances is equal to one model. These are the steps in machine learning. This is main important topic in machine learning, because to understand what is machine learning, how machine learning will work, flow work, these all are comes under these 7 points only. Here we can see first point, data collection. Data collection means for every model we need to give the data first. What type of data we are giving is the matter important here. Here for every time we are giving only raw data only. In the raw data we can have noise data, empty data, unused data. Okay, this type of data we have in raw data. Okay, to process the data we need to prepare the data in a correct manner, or to pre-process the data to the model before going to model. Here the second step is that is data preparation. Data preparation is nothing but removing noise. Okay, removing noise and empty values, unused data, all these are this type of data we can remove in data preparation. After removing noise data, we need to select the model based on the requirement or based on the problem. If the problem is related to classification, we need to select the classification algorithms only to solve that problem. If you if the problem is related to regression or clustering, we need to select related to that algorithm only. Okay, based on the problem, we can select. We have to select model. After that, we can see one by one here. Data collection till now I explained this only. Data collection is we are giving raw data only for the data collection. After that, data preparation is going. Data preparation we are removing noise data and unlabeled data or unused data. Okay, and empty data. All these type of data we can remove in data preparation or data pre-processing. Okay, third one, choose a model. Model is selection of model is based on requirement or problem only. Till now we discussed. Next one, train the model. After selecting the model, we need to train the model by using specific algorithm. Okay, here how the model will train by giving the data. Here the train the model means we are giving 100% of data to the model. First it splits the data. Model will splits the data to train and testing. Here 80% of data will use for training purpose. After that remaining 20% of data will use for testing purpose. What is the importance to split the data means here? If we want to if we want to test the data with trained data, we can get the 100% of performance, or we can get the 100% of output, because of we are training data and testing data is same. Whenever you are applying same data to the training and testing purpose, we can get the 100% of performance analysis. Whenever you try to with new data for testing, we can get vary in the performance analysis. For that purpose only, we are giving the training data is different and testing data is different. Next, evaluate the model. Evaluation of model is nothing but Analyzing the performance. Already I told we have different performance matrices in machine learning available. Some of matrices are mean squared error, root mean squared error, and F1 score, R1 score, confusion matrices, okay, supervised classification. These are all some of performance matrices. One of the example formula for performance matrices is 1 by n summation of j equal to 0 to 1, 0 to n, and the bracket y of j minus y of j bar and square. This is the one of formula to evaluate the performance. We have different formulas are there. We can use any formula based on requirement. Next, parameter tuning. Here parameter tuning means whenever you after splitting and after testing, we can get different performance or different outputs are there. Which one is better? Which one is giving better performance? The better performance means here, for example, if you take random forest algorithm, in random forest algorithm, we are using different trees with the same data. With the same data, different trees and different models, their different trees are giving different performances. We need to select the best performance from the which tree is the problem here. Here for the classification in random forest algorithm, for the classification problems, we are taking majority vote from the different trees. For the regression problem, we are taking average of the performances of different trees. In this way, we can evaluate the and we can tuning the performance by different models. Make predictions. Final, this is the last step. Make predictions. Here the predictions are taken by different models. Till now we discussed in previous step. Predictions are taking from which model is giving the best performance based on performance analysis by using different matrices. Different matrices only we can predict the output by using machine learning. These all are till now we are discussing workflow of the machine learning or different steps in we are using in machine learning. Okay, now we are going to see the some of applications by using machine learning. We can see traffic alerts. We can find traffic alerts by using machine learning. Next, social media. Okay, next, transportation and computing, products recommendations, virtual personal assistants, self-driving cars, dynamic pricing, Google Translate. Different nowadays we are using everything is AI. Okay, this is the machine learning is the subset of artificial intelligence. Nowadays we are using everything using AI only, artificial intelligence. For that purpose, we can find out different most of the problems we can solve with machine learning nowadays. Now we are going to see how the machine learning process will work. Okay, one of the main important topic is here. Multi-perceptron. Okay, multi-perceptron means here we are giving the input and process the input and taking the output from the process. Actually, machine learning is it is working as a biological network. In biological network, different nerves are we have. Different nerves are performs processes. Different processor performs nerves. Here in machine learning, in multi-perceptron mainly we have three types of layers. First one, input layer. Second one, hidden layer. Third one, output layer. Here in hidden layer, we can have a single hidden layer or multiple hidden layer. Based on multiple hidden layer, we can say it is a multi-perceptron. If we have single hidden layer, we can say in single perceptron. Okay. Here we are giving the inputs. inputs as the inputs as the nodes, and we are giving strength input weight here. Weight is nothing but strength to the input. Strength to the input we are giving to the hidden layer. After hidden layer, it will process the data here. In hidden layer, process the data, and we will get the output with output layer. Okay, this is the process of multi-perceptual machine learning. Okay, this is the video representation what we discussed till now. What is machine learning? Okay, here we can see we are taking the cube problem. Cube problem we can solve with machine learning. We can see here, this is the machine. Here we can say it is the example of reinforcement learning. Because of in reinforcement learning, we will get the reward for the right move, we will get the penalty for the wrong move. Here this is the machine problem solving cube. A problem we are giving the problems to as a cube. It will predict and it will solve the problem. This is the type of classification, dog and cat. We are predicting the what is the dog, what is the cat based on specification by using machine. Here we can see diagrammatical representation here. Machine will analyze the width, height, these are the values. Based on these feature values only, machine will predict the what is the dog, what is the cat, what is the cow, like this. Okay, you can see here the performance. This is the score. Here we are getting the reward for the correct move. That's why score will increase. Okay, this is also example of reinforcement learning. Okay, you can see here what's dogs need. Dog eat what type of food, like this. These problems are solved with machine learning. Okay, these are the spam of mails. In the mails, we can find out what is the spam mail, what is the draft mail, what is the sent mails. These are all comes under classification problems. This is the chess game. Chess game also example of reinforcement learning. In chess game, we can get the reward for the right move, we can get the penalty for the wrong move. This is the graphical video representation for the machine learning. Okay, till now we have discussed what is machine learning, types of machine learning, and what is the process of machine learning, and what are the steps, what are the key elements. These are all till now we discussed. Okay, in steps mainly 6 types, 7 types we discussed. Based on the steps only, total machine learning will work actually. Here from the data getting and after getting till the getting the output, what process is going in machine learning, these are all comes under different topics only. In this topic, in this video, we are discussing only introduction and basic level of machine learning only. After that, if you want to know, we need to go through different algorithms like this only. We have different types of algorithms also, I told. Okay, thank you. Till now what we discussed, okay, what we discussed all are completed with PPT and video representation. Once again, thank you all.